Welcome to Network 13. Today we built an Arduino party light. Okay, so I purchased these tricolor LEDs from an eBay seller recently, and what these are, there are 3 different LEDs in this package. There's a red and a green and a blue, and they share a common cathode connection. Now, if you look at the bottom, this doesn't matter from the bottom or the top, but there's a flat spot on the case, and I've numbered these 1 through 4 corresponding to what you see here, the anode for the red, the green, and the blue, and then the common cathode connection. These are diffused tricolor with common cathode. They're capable of withstanding 20 milliamps of forward current maximum and or 60 milliwatts power dissipation per LED, I'm assuming. And they are able to output between 4 and 5 lumens. I'm assuming that's at the maximum current. All right, this is our circuit schematic. I'm using an Arduino Uno, which is the model that I own. I'm using 3 of the digital pins that are also capable of PWM output. And I am syncing base current from these 3 PNPs through these 43K resistors. So the base currents turn out to be about 100 microamps, which is well within the safety rating of these PWM outputs, because what I don't want to do is ruin my Arduino. So you want to limit the current as much as you can into these pins. I know you see some people who sink 5 or 10 milliamps into these outputs. I don't feel comfortable doing that. I don't want to break my Arduino board. Over on this side, so when the PWM pin goes low, it will bias the PNP on, and we'll get our current through our LED. And if this one turns on, the green will turn on. If this one turns on, the blue turns on. The intensities will vary according to the duty cycle. We can put on a PWM pin, we can put anywhere from 0% duty cycle to 100% duty cycle. Of course, 0 would be, the LED would be off, and 100% it would be on, completely on. And anywhere in that range, if you set for 50% or 10% or 20%, it's going to be, the intensity is going to be different. And how we get different colors out of this is we mix different amounts or different intensities of these 3 red, green, and blue colors. If you look at my data here in the corner, the red LED drops about 2 volts, and the forward current is about 10.8 milliamps. The green drops about 2.7 volts at 4.1 milliamps, and the blue drops 2.8 volts at 5.6 milliamps. And the reason that these currents aren't all the same is that I was trying to match intensities of the red, green, and blue when they were on at 100% duty cycle, trying to match that. If you set all the currents to the same amount, the intensities are not equal. And what we're trying to do is get the intensities equal so that we're able to make our different colors, as you'll see later when I go through the sketch, the source code. But anyway, so we are pulling enough base current out of these to saturate these PNPs, so the drop from collector to emitter were very, very low, on the order of 100 millivolts. Okay, so I put the red and the green PWM channels from the Arduino on the scope here, and if we just wait until they're actually here we go, until actually doing that, the PWM outputs on the Arduino run at about 500 hertz, and as you can see, this one right now, where the red is going from high to low, and then the top channel is the green, that's going from low to high. The consequence of having to use the the common cathode LED in this circuit is that the PWM signals are actually inverted. So a 0% duty cycle coming out of the PWM pin will translate to a 100% duty cycle for the LED. It's just the way we had to build this. If you had a common anode connection on the LED, then you could use NPNs to drive them and everything would be correct. But we have a way to compensate for this in the Sketch software, as you'll see later. But here we go. So one's going up, one's going down. And now this is going up. Red is going up. Red is going down. And then it's off. We're recording this with the QuickTime screen recorder that's in OS X. We'll see how this works. Bringing up the Arduino IDE, as you all know, and this is the Arduino Party Light version 1.0. This source code, by the way, will be available on the Network 13 Google Plus page, along with the circuit schematic and some links. So we start off at the beginning. We declare 3 integers. We call them red, green, and blue, and we initialize them to 10, 11, and 9, which are the 3 PWM pins that we want to use. This next part is we are declaring 3 integer arrays, calling them red val, green val, and blue val, and these are 16 elements in each array. And we have values, all different values here, and these values are from this website, rapidtables.com, and these are the RGB codes for the 16 basic colors that you can make. Now, of course, obviously you can make an infinite amount of colors, but for the purposes of our demonstration, I wanted to just keep to these 16. And the basic colors we have are, of course, black, white, red, lime, blue, yellow, cyan, magenta, and so forth, all in this order. In the setup section, we are defining red, green, and blue pins, which are 11, 10, and 9, as outputs. And when we get to the loop section, the very first part of the demo, we will be displaying the 16 colors in order. So we will be pulling these RGB codes from these 3 arrays, and we'll set let's not start with black. Let's say we're going to do the red. So let's say we're at 2, index 2. So if n equals 2, we take red val 2, which would be 255. We subtract that from 255, and we set the red pin to 0% duty cycle, which corresponds to 100% duty cycle on the LED because our hardware is inverting this signal. The green value, which is 0, and the blue value, which is 0, are going to be set to 255 minus 0, or 255, which corresponds to 0% duty cycle at the LED, because we want them off. So we want to display just the red LED, we want the green and blue off, and so on and so forth. If you count through these, you get to the next one is lime and blue and yellow, and it's just different mixtures of different intensities of these colors, and you can get all these other colors. So the first part of the demo goes through the 16 colors, and we have a 750 millisecond delay after we set each color. After we're done with the 16, we're going to black out the LED for 750 milliseconds, and then we're going to start the part where we're fading. We're going to fade the red LED from 0 to 100%. We're going to keep the green and the blue off. So the way we do this is we have a loop where we're counting from 0 to 255. We're subtracting this number from 255, and we're setting the red to that duty cycle, which is inverted. The green and the blue we fix at 255, which would be 0 at the LED, which means they'd be off. So we fade the red from 0 to 100, and then we wait 20 milliseconds after each analog write call, or actually after this group of analog write calls, because we need to allow some time for the PWM pin to update. If we do this too fast, it's not going to work. Then we fade from the LED, red LED from 100 to 0, while we're fading the green from 0 to 100. So we're going to get, maybe some orange in there someplace. Then we're going to fade the green from 100 to 0 while we're fading the blue from 0 to 100. So we'll get some aqua someplace in there, possibly. We'll fade the blue from 100 to 0 while we fade the red from 0 to 100, and then we'll get maybe some violet and pink in there. And then finally the last part is we're going to fade the red from 100 to 0, which would be black. Everything will be off. And then we'll wait a second and we'll go back to this top of the loop and start over again, of course. Okay, I just hit the reset button on the Arduino and we're going into the demo mode. We're counting through our 16 colors that we defined in our RGB arrays in the sketch. And we get to the end, and then we begin our fading. So we're going to fade the red LED from 0 to 100. Then we're going to fade from red to green. And we're going to fade from green to blue. And we're going to fade from blue back to red. And we're going to go from red to black. And then we're going to start all over again. And as you can see, counting through these different colors. So the fixed colors, and then we have the variable, the fading. And there it goes again. Okay, that's our demo. That's the Arduino party light. And I will leave you by saying comments and suggestions are always welcome. Feel free to leave comments and suggestions in the comments section, or you can email them to network13.contact@gmail.com. We have other videos up on our YouTube channel. If you like what you see there, you may want to consider subscribing. We have exhibits for these videos are up on our Google Plus page, and there is a link to our Google Plus page in the About tab on our YouTube channel. And what else did I have to tell you? Let's need the light for a moment. If you enjoyed this video, please feel free to give it a thumbs up. And I think that's all I had to tell you. So I'll bring the house lights down and I'll bring the music up. And I will say, as always, thank you for watching.